Hey Siri, Alexa, okay Google. You know them, you use them, they're the little phrases that bring our smart devices to life in an instant. But have you ever really stopped to wonder how that actually works? It's not magic, but honestly, it's just as fascinating. So let's decode it together.
I mean, really think about it. How does that little speaker sitting on your kitchen counter, totally dormant, instantly pick out one specific phrase from all the other chatter and noise in the room? The answer isn't some kind of wizardry. It's just a really, really brilliant piece of engineering.
And this is the core idea we're going to unpack. Wake word detection. It's the tech that lets a device hang out in this super low power, always on listening mode, just waiting for that one special phrase. That's the signal that tells it to wake up and pay attention. This is what makes true hands-free control totally possible. So let's talk about the magic wake word. How does one simple phrase trigger an instant action? This is where the technology starts to feel less like a gadget and more like a genuine assistant, right? It creates this seamless, natural interaction, almost like you're just talking to a person. Here's a great way to think about it. Imagine you're at a really loud party. There's music playing, dozens of people are talking, glasses are clinking. It's just a wall of sound. But then, somebody across the room says your name, and somehow, your brain just picks it right out of the chaos. Well, wake word detection works in a very similar way. And this really gets to the heart of why it's such a game changer. Without this tech, you'd have to physically pick up your device and push a button for every single little command. Weak word detection just erases all that friction, making the whole experience feel incredibly smooth and intuitive. Okay, so how does the device actually do it? Let's break down the whole process. It's basically a four-step journey that takes a sound wave floating through the air and turns it into a digital command. Okay, so first, the microphone is in this constant, low-power monitoring state, just passively capturing all the sounds around it. Second, a super efficient model is sifting through that audio, looking for the specific acoustic patterns of the wake word. Third, once it thinks it has a match, it does a quick double-check to make sure it wasn't just a word that sounds similar. And finally, once it's confirmed, boom, it activates the main system and your assistant is awake and ready for your command. And this transition is the key to the whole thing. The device isn't constantly processing every single word you say. Nope, it just stays in this low-power, passive state until that one specific trigger is confirmed. And this is so important for two big reasons: saving battery life and, of course, protecting your privacy. So, what kind of technology is actually running the show here? Let's take a quick peek behind the curtain. We're not going to get lost in all the jargon, I promise, but it's pretty fascinating to see the basic building blocks. It all starts with the system's digital ears. These are audio libraries that capture the raw sound. That sound is then passed on to be analyzed by speech recognition tools. But the real brain of the whole operation is a machine learning model. This model has been trained on thousands and thousands of voice samples, which makes it an absolute expert at picking out that one very specific wake word from a sea of noise. All right, now that we know how it all works, let's look at all the places you're already using this technology, probably without even giving it a second thought. I mean, this technology has quietly woven itself into the fabric of our daily lives, from asking our smart home to dim the lights, to telling our phone to set a timer while we're cooking, or getting hands-free directions in the car. And this is so important. It's also a powerful tool for accessibility, allowing people to control devices without ever needing to touch them. But how do developers know if it's actually working well? Well, they focus on three key things. First, detection accuracy. Did it hear you correctly? Second, the false activation rate. How often does it wake up when it's not supposed to? And third, response latency. How fast does it react? It's a constant balancing act between being super responsive and, not being annoying. So what's next? The technology is amazing, but let's be real, it's not perfect. Let's look at the challenges being tackled right now to create the even smarter voice assistants of tomorrow. So, today's systems can sometimes struggle with loud background noise, they can be a drain on batteries, and yeah, they sometimes wake up by mistake. We've all been there. But the solutions being developed are incredible. We're talking smarter AI for noise filtering, more advanced pattern recognition to avoid those false alarms, and a huge leap forward called Edge AI. That just means more of the work happens right on your device instead of being sent to the cloud, which saves power and is way better for privacy. And this all leads to some really incredible future possibilities. Imagine creating your own custom wake words for your devices. Think about AI assistants that are so smart they feel completely natural to talk to. And as more of this processing happens locally on the device itself, we're going to see huge leaps in both our privacy and how fast everything works. Ultimately, wake word detection isn't just a cool feature, it's the gateway to a completely voice-activated future. It's the technology that turns a passive object into an active assistant. And that leaves us with a really fascinating question to think about. As our devices evolve into even better listeners, what new and amazing things will we ask them to do for us next?